British telecom research laboratories have played a key role in the development of optical fibre systems since they were first shown to be a reliable alternative to copper cable. In 1982, a major modernisation programme was initiated to transform the British telecom network to both digital and optical fibre technology. This programme is going to examine the progress that has already been made, as well as looking further into the future, towards a completely transparent network. But why, first of all, was this modernisation programme necessary?
Traditionally, the problem with communications has been one of bandwidth and distance. On cables of this kind, which are twisted pair copper with paper or plastic insulation, we can place 1,000 telephone calls with ease. We then replaced this type of cable with coaxial cable, and here we have 18 tubes of coax, and this cable is laid between London, Manchester and Birmingham. Every one of these tubes can carry all of the capacity in this 1,000 pair cable. Let me contrast that with optical fibre. I'm holding in my hand 7 optical fibres, and here is one of them. This one optical fibre can accommodate all the telephone calls in this 18 tube cable. We currently have 650,000 kilometres of optical fibre in the ground in the UK. About 100,000 kilometres of that is now in the local network feeding customers, and at the long lines end of the network we are carrying 65% of all the telephone calls in the UK on optical fibre. Without optical fibre we would not have achieved the global communication system that we have today. We would have run out of bandwidth for microwave radio systems, we would have run out of bandwidth on satellite systems, and there is just not enough copper available to give everyone the level of communications that they now enjoy. Today, optical fibre is providing about half the global communication capacity for long lines transmission. We're now progressing down networks towards customers. Fibre to the home has got to be the next big goal.
So how can this goal be achieved? Not only cost-effectively, but also in a way which will cope with the new and unexpected demands of the future. At BT Research Labs, the careful planning and development necessary for a largely transparent network is well underway. There is already a new system under development which will make optical fibre to the home a realistic proposition. This will be achieved by sharing fibre access between customers.
This new system is called TPON, T-P-O-N, which stands for Telephony on Passive Optical Network. And the key principle that it operates on is dependent on this new type of optical component called an optical splitter. In this device, 2 incoming fibres on this side of the coupler, and you have 2 fibres on the outside, on the other side of the coupler. Power coming in on one of the input optical fibres becomes equally split between the 2 fibres on the output side. Conversely, power coming in on the other side of the coupler, fed from both fibres into the coupler, becomes combined together so that the power from each of those fibres appears on each of the outgoing fibres. Now, by using these devices in arrays, it's possible to take the light from a single customer and combine it together with the light of many other customers and feed that light back on a single fibre into the telephone exchange. Equally, light from the telephone exchange can be fed out on a single fibre and split between many customers. Now, the second device that's of particular importance in realising these systems is the customer module. And what we're showing here is a mock-up of what we think such a customer module could look like in the future. And you'll see that it's realised in the form of a familiar termination box of the type that appears in your home at the present time. Inside, however, is a mock-up of a number of components, including the optoelectronics, the electronics to do the signal processing on the system, and also the electronics to interface this unit to the output socket, in other words to your telephone. The really important issue now is to implement a box of this type in sufficiently low cost form that it can be made available to the ordinary domestic customer, and this now remains the vital challenge for the future.
Until now, optical fibres have been installed mainly for the business customer, with many telephone and data lines. These are users whose commercial need can justify the cost of their own dedicated fibre, a fibre running direct to the exchange. But the TPON system can extend this distribution to the residential customer. This is made possible by having a number of customers sharing the same fibre and head-end equipment. The light from a laser travels from the exchange head-end to the cabinet splitter arrays, where it's first split using passive optical techniques. The optical signal then moves on to further passive distribution points, where it is again split and routed to as many as 128 residential customers. With optical fibres providing a direct, transparent optical path, many new broadband services could then be offered to customers. For example, video library services, cabled TV distribution, or high-definition television. Just some of the services which would start to make use of the vast bandwidth potential of the fibre. These could be introduced at different wavelengths before being combined with the TPON wavelength of the cabinet splitter and then distributed to customers in precisely the same way.